Welcome to Session 2 of our TI84 Calculator Primer. Today, we will explore graph analysis using the CALC menu and learn how to enter data for regression analysis. In today's session, we will cover two major skills: analyzing graphs with the CALC menu and fitting models to data using regression techniques. We'll look at features like finding values, zeros, minima, maxima, and intersections, as well as how to enter data, create scatter plots, and perform linear and other types of regressions. Let's start with an overview of the second CALC menu. This menu includes options for evaluating values, finding zeros or x-intercepts, locating local minima and maxima, and determining where two curves intersect. Today, we will focus on the first 5 options, while the remaining options are calculus tools you will use later. The value feature allows you to evaluate the function at a specific x value within the current window. After graphing a function, you can access the CALC menu, select the value option, enter your desired x value, and press enter. The calculator will show you the corresponding x-y point, making it a quicker alternative to using the table for checking a single point. Now let's find zeros step by step. First, graph the function in y1. Then, access the CALC menu and select the zero option. You'll need to set a left bound by moving the cursor to the left of the zero and pressing enter, then do the same for the right bound. Finally, make a guess near the zero and press enter again. The x-intercept will be displayed at the bottom of the screen. The zero feature is specifically designed to find where the function equals 0, or the x-intercept between two bounds. Remember, the function must change sign between these bounds, meaning it crosses the x-axis. Always find one zero at a time, and if there are multiple roots, repeat the process for each one with different bounds. Let's work through an example to find the zeros of the function y equals x squared minus 5x plus 4. Start by entering the function into y1 and then press zoom 6 to graph it. Use the zero feature to find the left root first, and then repeat the process for the right root. You should find zeros at x equals 1 and x equals 4. You can verify this by factoring the equation. Next, let's find extrema, which are the maximum or minimum points of a function. Start by graphing the function in y1, then access the CALC menu and select either the minimum or maximum option. Set your left and right bounds around the extremum and make a guess near that point. The coordinates of the extremum will be displayed at the bottom of the screen. The maximum and minimum options in the CALC menu allow you to find local extrema between two bounds. Just like with the zero feature, you will set left and right bounds and make a guess. The calculator will report the x, y coordinates of the extremum, which is particularly useful for parabolas that open up or down. Let's find the vertex of the function y equals negative 2x squared plus 8x minus 3. After entering the function into y1 and pressing zoom 6, use the maximum option since this parabola opens downward. Set your bounds around the peak and make a guess. You should find a maximum at the coordinates 2, 5. You can also verify this using the vertex formula. The intersect feature allows you to find where two graphed functions cross each other. To use this feature, graph both functions in y1 and y2. Access the CALC menu, select the intersect option, and then press enter on the first curve and again on the second curve. Finally, make a guess near the intersection point and press enter. Let's go through the steps to find an intersection. After entering both functions in y1 and y2, press graph to see them plotted. Then, access the CALC menu and select the intersect option. When prompted, press enter on the first curve, then the second curve, and make a guess near the intersection point. The coordinates will appear at the bottom of the screen. Now let's solve a system graphically. We will solve the equation x squared equals 2x plus 3. Start by entering y1 as x squared and y2 as 2x plus 3. After graphing, use the intersect feature twice to find both crossing points. You should find intersections at the coordinates -1, 1 and 3, 9. This graphical approach is powerful, especially when algebraic methods become complicated. It's time for some practice with graph analysis. Try graphing y equals x cubed minus 3x and find both the local maximum and local minimum. Additionally, identify all the zeros of the function. The expected results are a local maximum at -1, 2, a local minimum at 1, -2, and zeros at approximately negative square root of 3, 0, and positive square root of 3. Now let's shift our focus from analyzing equations to analyzing data and regression. We'll learn how to fit models to real-world data using our calculator. To enter data into lists, press the Stat button and select the Edit option. Enter your X values in list L1, pressing Enter after each value. Then arrow right to L2 and enter the corresponding Y values. If you need to clear a list, simply highlight the list name, press Clear, and then Enter. Remember, L1 and L2 must have the same number of entries. Next, let's set up a scatter plot. Press the second button followed by Stat Plot, then select Plot 1 and turn it on. Choose the scatter plot icon for the type, set X list to L1 and Y list to L2, and press Zoom 9 to auto-fit the window. This will adjust the window to display all your data points clearly. Here's a step-by-step guide for entering data in lists. Start by pressing Stat and selecting Edit. Enter your X values in L1, pressing Enter after each one, then move to L2 to enter the corresponding Y values. If you need to clear a list, highlight the list name, press Clear, and then Enter. After entering your data, remember to access Stat Plot and use Zoom Stat to see your scatter plot. Now let's perform linear regression. Press Stat and arrow right to the Calc menu. Select the option for linear regression, which is labeled linreg with the form ax plus b. Set X list to L1 and Y list to L2, and store the regression equation in Y1. When you press Calculate, the output will show you the values of a, b, r squared, and r. A value of r squared close to 1 indicates a strong linear fit. To run a regression, start by entering your data in L1 and L2 as we discussed. Then, access the Stat menu and select the regression type you want, such as linear regression. Set X list to L1, Y list to L2, and store the regression equation in Y1. After pressing Enter to calculate, you will see the regression equation displayed, and you can graph it to see how well it fits your data. In addition to linear regression, there are other regression options available in the Stat Calc menu. You can choose quadratic regression for parabolic data, cubic regression for cubic data, exponential regression for growth or decay patterns, logarithmic regression, and power regression. Always select the model that best matches the shape of your scatter plot and compare r-squared values to determine the best fit. Let's fit an exponential model to some data. Enter the following data. In L1, input the values 0, 1, 2, 3, and 4, and in L2, input the corresponding heights 1.0, 1.5, 2.3, 3.4, and 5.1. After creating a scatter plot, run both linear regression and exponential regression, recording the r-squared values for each. You'll find that the exponential model fits better with an r-squared value close to 1. Now let's discuss storing and recalling values using the STO key. You can store a value into a variable for later use by typing the value, pressing the STO button, then alpha followed by the letter you want to use, and pressing Enter. For example, to store the number 42 in variable a, you would type 42, press STO, then alpha a, and Enter. You can recall this variable in any expression simply by pressing alpha and the letter. For our final practice, consider this scenario. A ball is dropped, and its height and feet is recorded at different times in seconds. The time values are 0, 0.5, 1.0, 1.5, and 2.0, and the corresponding heights are 64, 60, 48, 28, and 0. Enter this data and create a scatter plot, then run quadratic regression to find the model. Finally, determine at what time the ball reaches half its initial height. To recap today's session, we learned about graph analysis using the second Calc menu, including how to find values, zeros, minima, maxima, and intersections. We also explored data entry and regression using Stat Edit for data input, creating scatter plots with Zoom Stat, and comparing different regression models using r-squared values. Don't forget about the STO key for saving values for later use. In our next session, we'll dive into matrices, sequences, combinatorics, and special graphing modes.